Okay. So we'll get started here. Can everybody see my screen okay? Great, thanks. Yeah, so I'm James Losee. I'm with Washington Department of Fish and Wildlife. I'm the Regional Fish Program Manager for Region 6. And so that's the Washington coast, South Puget Sound and Hood Canal, and then the Strait of Juan de Fuca. And so it's essentially, if you're west of the mountains, those are the fish that I'm thinking about. And I'm going to talk today about Hood Canal summer chum and some of the work that's been going on there. And this isn't a presentation I've given before, which is fun because there's, new material and I've pulled some information maybe that others haven't shared in the past. And the big focus of this presentation is really going to be about salmon diversity, specifically around Hood Canal and even more so with summer chum. So,
James, James, it's showing your presenter view.
Oh, is it?
Yeah.
We can fix that. Thank you for that. At least we can do our best to try to fix that. Okay, let's try this again. How does that look? Okay, I'm just gonna get my pieces in place here again. Oh, it lost you, didn't it?
There you go.
Thanks. Might lose you one more time. I'm gonna try this one more time. It really likes my second screen, so apologize for not testing this out before. Okay, well, let's just move forward. And then this is the main slide that I was really hoping to have those notes. And the reason for that is because there's a lot of people involved in this work. So it's a little awkward showing this slide with my name only on it because, there's a whole group of people. And so when we get to the end of this talk, we'll just list those names that I've got in that notes section so you guys know, because the Hood Canal Summer Chum project and the recovery efforts are really based on this large collaborative effort. So that's super important, and I don't want to forget that. So again, I'm gonna use the comment box here, and I think everybody that's on now captured that before, but actually with only 4 of us here, I'm gonna have you just unmute, and I can see everybody here. If you don't need to turn your camera on, but if you've got a question, maybe unmute or put your camera on and just raise your hand. And the way I'm set up here, I'll see that really well. And I encourage you to interrupt me here as I go. I think we've got about 20 or 25 minutes of material, so feel free to interrupt. So this is a Hood Canal summer chum right here in the picture. And I'm gonna start this presentation by sort of zooming out a little bit and talking about Puget Sound salmon sort of more broadly, and then sort of slowly zoom in on Hood Canal summer chum and then the recovery efforts that have taken place. So just make sure we're still on the same page. That second slide is looking fine, and then we'll be off on our way. So if not, just holler. So there's a lot going on in this slide. The map you're seeing on the right, this is the Salish Sea, or the southern portion of it. So this is Puget Sound, and a lot of this stuff, I know there's folks that already understand this, but it's pretty important for framing Hood Canal specifically. So Puget Sound is sort of characterized by these unique fjord-like inlets. So there's all these cool little fjords, and Hood Canal here in blue represents sort of the largest fjord in South Puget Sound. what's really exciting about Hood Canal, I think, is depending on which side, whether you're on the west or the east, your systems are dominated either by glacial flow or rain dominated systems. So right there, it's super diverse, Hood Canal, even more so than any of these other fjords in the southern Salish Sea. So this key might be hard to see on your end, but you can just see that we're looking at North Puget Sound. This is up by Bellingham. And then down here in the south, this is where I'm at today, is in Olympia. So this is South Puget Sound. And then in blue is Hood Canal. And then we'll talk a bit about the Strait of Juan de Fuca as well. So I've put down here, actually, I think if I click here, I can circle that so everybody can zoom in. So down here, I've put 7 pictures, and this is important to me because we often think of Pacific salmon as these 5 main species of Pacific salmon. So, we talk a lot about chum and pink and sockeye, Chinook salmon and coho, and those are the big players, the big commercially kind of relevant species. So those are listed here as these first 5, and then when you move over to the right, you see steelhead. So this is an anadromous trout. And then cutthroat trout as well on the right here. So these are the 7 big players. And what's cool about Hood Canal as well is that all 7 of these exist, and there's viable populations of each of them. Today we're going to talk about chum salmon specifically. So we're going to kind of blow up chum salmon so you can get a good look at these fish. And I don't know how familiar everyone is, but chum salmon are an awesome critter, and we'll sort of talk a little bit more about the biology of these fish. So any questions on kind of that map or what we showed so far? If not, I'll just keep moving. So I'm going to spend about 10 seconds on this slide because I think folks are really comfortable with the salmon life cycle, but it's just important to note that chum salmon, like other Pacific salmon, spawn in a freshwater environment. They immigrate out of the gravel and into the estuary and the marine water. So this is what makes them anadromous. That's the word we use for fish that are utilizing both of these environments. What's really cool about salmon, of course, is that they're returning to their natal stream to spawn. And that's super important for Hood Canal summer chum. Because salmon, they're emigrating out of one of these independent tributaries of Hood Canal. They're moving to the coastal environment or into southern Alaska. And then 3, 4, and 5 years later, they're returning back to Hood Canal to the same stream that they originated from. And that's, of course, where they spawn and die. So that's the end of the salmon life cycle. So here we've got, a large adult salmon, and this is really the period we're going to focus on today because we're talking about recovery, and we're excited about juvenile fish and all the different stages of the life cycle, but our sort of benchmark is how many fish we get to the end of the road. So we're going to focus on this returning back to the marine water where fish are encountered and harvested by fisheries and wildlife, and then where they return to the river and spawn. So this is the zone we really care about today. So again, this is a quick one. We know salmon are super important, and they support a diversity of wildlife and have ecological and economical significance. There's some citations down here I've shown that are just documentation of how important these salmon are to sort of the larger ecosystem. And so these papers are talking about, one of them documents 22 different species of wildlife using one individual salmon. This was a really neat study that I can share later if folks want it. And then the Cedar Home papers is identifying the importance of marine-derived nutrients in, the body of a grizzly bear. And so if you look at the bones of a grizzly bear or a black bear for that matter, you find out that these are not marine critters, right? They hang out in the terrestrial environment and feed from rivers, yet, greater than 90% of their diet is comprised of nutrients from the marine environment. So we know the only thing that could have done that is likely a salmon or a lamprey, some other anadromous creature. So we know that salmon are super important. And so this is sort of answers the question, why summer chum? Why are we caring about summer chum? And this is really the answer in this picture that I really like. So just sort of carry on with that message, this salmon has been consumed by something, and you know, the tail is left here, and that's really not the end of the road, right? This is great fertilizer, and we can think of, you know, hundreds of reasons why a dead salmon laying on the bank or one that's fed, you know, the ecosystem is super important. So, and this is also, like I say, our major benchmark. So this is our scorecard. Seeing dead salmon that are spawned out and completed their life cycle, as a fish manager, that's a big win for us. So this is really, you know, among all the goals and objectives we have, this is the main one, right? Seeing fish return to their natal stream and spawn. So that's a chum salmon tail there. So I think folks are on the same page with this too. There's lots of names for chum salmon, dog salmon. Their scientific name is Oncorhynchus cata. So if you see cata salmon in the grocery store, that's what you're looking at, is chum salmon. You know, they're healthy actually. When we talk about salmon, chum salmon are the big victory broadly. But when we zoom in on Hood Canal, we notice that there's this you know, this run type summer chum that are threatened under the Endangered Species Act. So they're actually a little bit of a black eye, but the good news is for summer chum is there's been a lot of attention because of that. So there's some life history information I've mentioned about when they go out to sea. So they're a saltwater fish, and we think about tuna and sharks and these other saltwater critters, and you know, they spend 100% of their life in the saltwater. Well, chum salmon aren't really much different than these other marine species of fish, because you know, they leave when they're, you know, less than 2 months old, as these small fry, and then they spend 3, 4, or 5 years in the saltwater. They return to freshwater, where they survive about 10 days in the freshwater environment. So they've got clocks ticking the minute they hit that freshwater. They've got about 10 days to spawn and then die. So I like to think of them really as a marine fish that spends this limited amount of time in freshwater, where we get to count them and see how we're doing. So summer, fall, and winter, these are 3 distinct run types, and I'll talk more about that. And of course, we're going to talk about summer specifically tonight. So here's this first sort of data slide, and I like these data slides, so please stop me if something gets confusing, but I'm going to walk through this one. On the x-axis, that's the horizontal axis here. You can see the time from 1968 to 2013. And the top of these colors represents the number of salmon that returned as adults to Puget Sound. And each color is a different species. So if you come all the way to the end here in 2015, 2014, actually, you can see that about 12 million salmon, like large-bodied adult salmon, came into Puget Sound. So right through the Strait of Juan de Fuca, and we're headed for Puget Sound. So that's a lot of fish. You can look at which species were comprised of those fish. And of course, pink salmon are a big deal now. We've seen them in the news, and populations have just exploded recently in the last decade. And they're odd year, right? So they do this sort of teeter-totter. Every odd year, 2013, 2011, 2009, you can see we've had these huge pink years. But I think what I find really interesting is when you walk in a grocery store, you see a lot of Chinook and coho, steelhead, a little bit of pink salmon, some chum salmon. But when you look at green, that's chum salmon. What you see is this whole time series, chum salmon make up a huge proportion of the total number of adults that come back. So when we talk about marine-derived nutrients and fish spawning in Puget Sound tributaries, chum salmon are a major player, and in even years, they're the major player. When you think about their life history as well as these fry going out to sea, if you end up with a couple million chum salmon spawning in Puget Sound, and we imagine that each one of them has about 2,000 eggs or so, that's a lot of juvenile fish, a lot of biomass coming and going just from chum salmon. So they're a big deal. So that's kind of the salmon background. So we're all on the same page with the species and what we're talking about. I'd maybe take a pause, and if anybody has any questions about what I've shown so far, feel free to just raise your hand or holler. Okay, we'll keep moving then. But again, don't be afraid to interrupt. So the second bullet is speaking more specifically about Hood Canal. I call it the Big Fjord in South Puget Sound. And we'll get ourselves to where we're talking specifically about summer chum. So there's a lot of words here, but if we start here with these bullets, I think they're pretty important. And you know, the theme is really diversity and salmon chum, summer chum being distinct. And so this first bullet says summer chum return to natal streams. We went over that, but they return in August and September, and that's special. So this graph down here shows the return timing of summer chum, fall chum, and winter chum to the farthest right. And so how this graph works is you're moving across time here within a given year. So you've got September all the way to January during this time when most of our salmon are spawning. And then this dotted line represents 50% of the fish that have come in already. So what this is showing is the time when these fish are moving into these rivers, and we're counting them as fish biologists in the river. And you can see that September 1 is when we start to see these summer chum. And then, you know, by about the end of September, we've seen about 50% of them. So that's the peak of the run. And then as you progress through September and into October, you see 100% of the run has come in the door. So summer chum spend about a month coming into the river, and each individual spends about 10 days. So you can see you've got about this 30-day window where summer chum are in the river as you know, a population. What's really cool about that is if you move down the road within Hood Canal, you start to see fall chum come after that. So by the time summer chum have completely finished their spawning activity, we see fall chum show up. And then in places where we have these unique winter chum, we see them all the way into Christmas. So the 100% of the winter chum haven't finished spawning until, you know, essentially the new year. We don't have any winter chum in Hood Canal, but it's important to know that there's this diversity and distinctness throughout Puget Sound, and there's probably a reason for that, right? They're each threading the needle for their own niche. So this is pretty exciting. I think that summer chum is just kind of off the deep end. They're so much earlier. So the second bullet sort of describes that. They spawn from September through mid-October, which is super unique. The water is really warm and low during that time. That's like right now. And then they emerge from the gravel really early too, right? They lay their eggs, spend about 30 days in the gravel, and then the fry pop out of the gravel. And then into winter and spring, we're watching these fry go out to sea. So like really a blink of the eye, these things have spawned, completed spawning, and then the juveniles are out the door. So this last bullet says spatially, temporally, and genetically distinct. It's kind of a mouthful, but it's pretty important. You know, spatially, these different populations are in different areas, different rivers. Temporally, so seasonally, you can see they're not overlapping in time. And then genetically, because they're not sharing genetic material, so summer chum are not spawning with fall chum, so they're genetically distinct as well. So that's really special in how we recover a population like summer chum. So this is sort of to just drive this diversity and distinctness home and think about sort of summer chum in the big picture. So again, we've got all of these different years here on the x-axis, and this one's a little different. I really like this graph, and I imagine it being sort of what an orca sees, or a large predator that's looking for salmon in the marine water. Each one of these lines represents 1 year, and each color within a year are the species that returned to Puget Sound in that year. So again, you see these pink teeter-totters, right? These odd year pinks, they come and they go. So in even years, you better not see a bunch of pink in there, because we don't have even year pinks in large enough number to really detect or enumerate. The other thing you notice, if you're that orca or that predator and you're moving through Puget Sound in any given year, this is sort of the salad bar, the different species. And these green represent chum, and there's these three kind of flavors of chum, right? Winter, fall, and summer. And so we know that these chum occupy different times and different spaces, and they're genetically distinct. So this is sort of this diversity. How diverse are we in Puget Sound? And this very top green color, this is mint green. If you look over here at the key, that's summer chum. You can see that it's just a speck. And then in pink years, it's this tiny proportion of the total salmon abundance that shows up to Puget Sound. So a lot of folks in their life will never see a summer chum. They don't have them in their watershed. And even when they do, they're blink of an eye. They're in there for a month. They're in low numbers. And some of that is natural, right? That they make up a small proportion of the total salmon abundance because they occupy this really unique niche. They're showing up at the hottest time of the year, and their juveniles are out migrating during the coldest time of the year. So this is a really special fish while it's low in number, and likely has been for quite some time. So if we ask, okay, we're starting to zoom in on these summer chum, where are summer chum? So there's summer chum in South Puget Sound, and there's some summer chum in Central Puget Sound, but the bulk of our summer chum for Puget Sound are in Hood Canal and the Strait of Juan de Fuca. So when we talk about Hood Canal summer chum, we're talking about these two distinct units. So we call these ESUs, or evolutionary significant units. So we've got the Strait of Juan de Fuca unit and Hood Canal. So if we were all together in the same room, I would sort of orient us. We would be, likely somewhere in Hood Canal. But, if you were to head south here, you would hit Olympia. And I'm going to trust that everybody here, if you're on a Hood Canal summer chum presentation, you have a general idea where we're looking at. If you don't, let me know. We can find another map to zoom out. But so here we've just circled these two significant units. And then on the right here, we've got these numbered sort of awkwardly. It's hard in a presentation to grab at each one of these. But the idea here is that these are spread throughout Hood Canal. And we know Hood Canal is an extremely diverse place. And so we've got summer chum that are occupying these rain-dominated systems, these that are deep in Hood Canal and dominated by glaciers. The Skokomish is the southernmost population. And then, of course, the group out here in the Strait of Juan de Fuca immigrates right into the marine environment. I mean, I think about 60 to 80 miles from the Pacific Ocean, these little tiny chum salmon are migrating out into the strait. So very different places within this map. So to sort of beat home this genetic diversity within that system, this is a really cool kind of cluster dendrogram or tree. And I have all kinds of notes that I can't see and you guys can't see here. I'm not a geneticist, so I'm going to fumble through this, but there's only a couple key pieces that are really important. The other thing that's in my notes is the reference to this paper. And so make sure when we get to the end, there's 3 or 4 really important documents that I'm sort of using to put this together, and I can share those with everybody if they're interested. So what this tree is really describing is genetic diversity. And so the length of these lines represents how distinct or how genetically different these populations are. And so on the top here, you have Puget Sound, summer and fall chum salmon. So these are the summer chum that I spoke about that are in deep South Sound, not in Hood Canal. And they're very similar to their neighboring fall chum salmon, right? Because they share similar rivers and they may be separated in time, but they're very similar in space. So they're out here in their own circle. Here we have Canadian fall chum salmon. So they're very different. They have their own branch of this tree, Sinclair Inlet and Colvos Passage. And then here we get to the Strait of Juan de Fuca summer chum. These are these 3 populations here that are identified. So this is the Little Quilcene, Snow Creek, and Salmon Creek. And then over here we come to the Hood Canal summer chum. So these are the 2 groups we'll talk about. And you can see that while they're really close to each other, and geographically, they're genetically distinct, suggesting they're not spawning together, not sharing genetic material. Rather, they're doing what salmon are supposed to. They return to their natal stream where they spawn. As a fish manager, this is super important because when we're trying to recover a population, whether it's Chinook, coho, chum, cutthroat trout, whatever it is, one tool we have is to bring wild fish into a hatchery setting and raise them and then release them into the stream of interest that we're trying to recover. So for looking at the genetics here, we know that this was an important tool for recovering summer chum in Hood Canal. So we can kind of ask ourselves, if we're trying to recover number 7 here, so that's Quilcene Bay population, you know, and we know this thing's, you know, extirpated or close to, where would we want to go get genetic material or salmon to, you know, to boost a recovery effort for this population? And this tree can guide that. We could look at neighboring populations genetically, those that are very similar, that also happen to be very close spatially, geographically. So this helped folks design these early recolonization efforts. So if you chat with one of the geneticists that did this, so Mo Small is the geneticist with Washington Department of Fish and Wildlife, who did a lot of this work. Maureen Small is her name. If you chat with her, let her know we didn't totally fail in describing this genetic slide. So there's not a lot of pictures here, but if I were sort of redo this, now I see this on the big screen, I would sort of show it, you know, sort of horizontally, like we think of a timeline, and that's kind of what we're looking at here. We have these years, the 70s, the 90s, and into the early 2000s. There's sort of our timeline to tell the story of Hood Canal summer chum. And it's a bit of a shame that it starts in 1970, but I think there's, you know, probably a huge high five to folks that identified really early that there was an issue. So in the 70s, that's really where our timeline begins for counting chum salmon. There were biologists in the 50s and 60s that were definitely out there identifying these populations and counting them. But the statistics definitely began in the 70s. And this is in large part due to people noticing, you know, we should probably keep track of these things. It feels like there's less than there used to be. So that's what happened. Folks noticed, you know, there was a significant downturn. A day of fishing for summer chum is a lot different in the 70s, apparently, than it used to be in the 50s and 60s. So then, you know, 30 years of head scratching, thinking about potential causes of this decline, until state and tribal co-managers adopted this harvest-based conservation regime. And what this really does is it provides guidelines for how many fish should be harvested and sets restrictions on you know, fisheries that are targeting summer chum, as well as those that are incidentally encountering them. So this was a really big deal because fishing in Hood Canal is important, but fishing, you know, across the entire distribution or migration corridor for salmon is important. And we know that summer, fall, and winter chum are being encountered, you know, far away from Hood Canal. So identifying that fisheries might be one of the causes early on was really important, and you'll see that later. So then a couple of years later, as you know, the co-managers and the state kind of took it upon themselves to identify some of these goals for fisheries, NOAA, or National Marine Fisheries Service, determined the summer chum originating from Hood Canal and Strait of Juan de Fuca constituted this ESU. So that was the genetic information we shared. You know, that it's kind of this distinct population segment. It's different than fall chum. It's different than winter chum. It's also different than summer chum in other places. So this is all really recent that this is occurring. You know, the mid 90s is when we're sort of uncovering kind of the secrets of these summer chum. And so then, of course, in 1999, they're listed as threatened under the Endangered Species Act, along with steelhead and Chinook salmon. So they sort of join this group of species that are identified really on like the big screen, like these are of concern. And that was a really big deal for summer chum because it was met with a bunch of funding as well to target the recovery efforts. And then in 2001, something really special and unique happened that I wish I was a part of, because it's pretty exciting that, you know, the co-managers and NOAA identified both the harvest piece, but also these artificial production tools that we could use to try to, you know, bring back summer chum. And so a really unique hatchery program was developed. And I think there's an argument to be made that it's working. So there's a lot of other timeline, you know, there's also a whole group of names I'm going to list off here at the end. But if those folks were on the phone, I don't see any, but if they were here, I think maybe there are folks on the phone that were a big part of this recovery effort that I haven't met. I think folks would realize that I'm missing a lot of really important timelines. So there's about 500,000 conversations and negotiations and just critical collaboration that led to this pretty phenomenal recovery effort. So I want to highlight that and also make it real clear that, you know, I can't take credit for that work. So we've talked about, you know, the background of Puget Sound salmon, a bit about Hood Canal summer chum. So we're all know we're talking about, you know, this special critter. I'd take another pause and make sure that there's not a slide we want to go back on, or there's no questions what we've covered so far. Okay, so this sort of next segment, I think, you know, I'm thinking there's maybe 6 or 8 more slides, and these are really sort of documenting this recovery effort that, you know, we've got recovery programs all across the state and across the whole West Coast for these different stocks. And I think right now there's folks arguing that summer chum might be the model. And so it was really fun putting together these slides to sort of try to unearth, you know, the pieces that people put together for to recover these fish. So you hear this VSP quite often, you know, in the terms of VSP parameters. And so these VSP parameters are really important because they're these specific goals and specific targets that we can sort of use as milestones to document our success or failure in recovering populations. So the definition is it's an independent population of Pacific salmon or steelhead trout that has a negligible risk of extinction over a 100-year time frame. So that's where we use these VSP parameters. These 4 main ones that were identified for the summer chum recovery were abundance, of course, the number of adult fish, and we're using the number that return to spawn as really our trigger. We like all these fish that show up to the Strait of Juan de Fuca, but we've got ambitious fishermen, and we've also got orcas and other large predators that are utilizing summer chum. So we're really interested in how many hit the spawning grounds and completed their life cycle. We want to know productivity. So this is the average number of surviving offspring per parent. So we really want to know, are these parents, not only are they making it to the spawning grounds and you know, and dying, like completing their life cycle, but are they successful at finding a mate, depositing eggs fertilized eggs into the gravel, and those juveniles are then productive, rearing in that freshwater environment for that limited amount of time. So that's our productivity. And then spatial structure, we know summer chum, if we had it like we did in the past, these were sort of geographically, sort of spatially, temporally, you know, diverse. And that's really important because in many places we set a numeric goal. We have that abundance or we have that productivity, and we may have an amazing habitat project that really increases abundance and productivity in one watershed. And it might even increase it to a point where it's never been, and we can all high five and ribbon cutting ceremonies and count the chum and be excited. But summer chum for us and all the folks involved in this recovery work, you know, involves this real diverse picture of what a summer chum is. And that's going to be really important for the long-term sustainability of these populations. And then that goes along with this diversity piece. We want both genetic and life history diversity. So they're not all coming in at the same time. They're not all leaving at the same time. and they're not all from one river that we're just seeding throughout the Hood Canal. We have very genetically distinct populations, and that would be the goal. So here's sort of a boring table here, but it's pretty key. So this is really the benchmarks that were created in 2003, and then were recognized by NOAA about 5 years later. And so again, we have these adult recruit numbers for each one of these rivers, and these are sort of these key indicator populations in the Strait and Hood Canal. And so adult recruits, this represents the number that are returning to Puget Sound. So these are the juveniles that went out to sea and survived. So that's an important number to track. And then we have the actual number of spawners. And so what you can see is if we take Jimmy Come Lately, that's this first one here, and we look at the number of adult recruits, 520, that would be our goal, with the understanding that a couple hundred of those fish, about 190, are actually gonna get removed in fisheries or other places before they reach the spawning grounds. So you could call this a lot of things. You could call it a buffer. We know that if we shoot for 330 coming into Puget Sound, we know we're not going to end up with 330 on the spawning ground. So we have these two sort of shared goals that then allow us to operate fisheries and model the impacts that we expect before these fish come to the spawning grounds. So it's, like I said, it's kind of a boring table, but it's really critical that this work was done, that there's these clear targets, not for Hood Canal broadly, not for summer chum as a whole, but rather these, 2 ESUs, these evolutionary significant units, and then broken down by stream. So it's, as a younger fish manager, it's just, I hope folks are really proud of this work. It's a pretty big deal, like what's wrapped into this table. And so there's kind of these key elements of the recovery plan implementation. So this BCR represents those harvest restrictions. We have these, super weak populations that that we know that there's still surviving individuals there, but we need to boost them. And so the tool that was developed at the time, was to bring some of those wild fish into the hatchery, rear them, have them sort of escape that critical period of mortality, and then release them back into that watershed. In places where we had, I should stop and say, in the second bullet, Salmon Creek, I'm going to show a picture of that. That's near Snow Creek. I'm going to show a picture of the first fish that just returned this year, last Saturday. The first summer chum just returned to Salmon Creek. So if you get a chance, this is a great one to go see a summer chum, where there's a trap that is a temporary trap that's put in place to handle these fish and monitor their numbers. So this is a special one along with these others. And then reintroduction of extirpated populations. This is where we could actually take neighboring genetic material or fish, bring them into a hatchery setting, and then release them into these watersheds of interest. So Chimacum, Big Beef Creek, and the Tuhuia. So these are those populations that don't have summer chum for us to use to boost their populations. And then expansion of spawning surveys. So like I said, pre-70s, the data quality just is not great. And these were great biologists, but this was right during the time of decline. So this is a WDFW stream surveyor, Riley Freeman. So he's out there counting fish. And this is a cool photo because you can actually see a fish right here. Like he's kind of a fish whisperer just hanging out underneath his raft. So we've really boosted efforts around monitoring summer chum. And I say we is kind of like the large we. So Hood Canal Salmon Enhancement has been a huge leader. Point No Point Treaty canceled. I mean, there's like a whole list of groups that have come together and tribes and state organizations and federal and nonprofits that have come together to lead this work. So the spawning ground survey and juvenile out-migrant monitoring is a huge collaborative effort among, federal, state, tribal, and then, private and nonprofits. And I should say in bold, volunteers as well. And then of course, habitat restoration has been a huge one for summer chum. And there's been specific examples of places where habitat recovery work has actually opened up new habitat or restored habitat for specifically summer chum spawning. This picture up here is of a purse seine. This is a really popular way for commercial fisheries to target chum salmon. And, you know, targeting fall chum later in the season or Chinook or coho is a great way to accidentally bump into a summer chum. So fisheries have been curtailed around that very specific summer chum spawning and migration period. So this is really cool. Most of these slides with lines, you see them, and you know, if they drop down like this, it's a really bad thing. So every time I look at this slide or this graph, I sort of like, my stomach drops like, okay, this is bad. It used to be high and now it's low. But this is actually really good news in this graph. So these blue and red lines represent exploitation rates. So that's the percentage of fish that are exploited or harvested before they reach the spawning ground. So if 100 come to Puget Sound and we kill, you know, the co-managers and all fisheries kill 50% of them or 50 fish, then our exploitation rate is 50%. So this is pretty amazing. For hood canal populations, you can see that we had exploitation rates in the 80s that were greater than 80%. So that means that 80% of summer chum that were returning to Puget Sound were harvested before they reached the spawning ground. So when we talk about sort of easy dials to turn, or shouldn't say easy, but quick dials that we can turn, they'll have a huge role in recovery. There's no argument that fisheries were one of those big dials we could turn. So you can see that, you know, through these fishery changes, harvest rates moved, you know, on average in these 60 to 80% ranges, down to lower than 20. And so these exploitation rate guidelines are these dotted lines. And so you could see places where we've exceeded these guidelines, you know, a couple for both the blue and the red. And it seems like, you know, that's a pretty bad deal, and it is. But I would suggest that we sort of think, you know, how those are met. So we forecast or make a prediction about how many fish are going to come back, and then we design fisheries associated with that prediction. And so I'm actually looking back in time thinking that folks did a pretty amazing job of making predictions. These are co-manager agreed to forecasts, and then designing fisheries around an unknown number of fish that will return. And then designing fisheries targeting other species while trying to avoid summer chum. So this has been a really effective tool, it appears to me, to curtail these fisheries and exploitation rates on summer chum. So there's a lot happening in this slide. So again, feel free to interrupt if you've got questions. So I'm sort of like zeroing in here. We're only got a couple more slides, and I've got two that look like this. And so these are sort of our standard, you know, trend plots that show how are we doing relative to the past. And on the top, I have Strait of Juan de Fuca populations, and then here I have hood canal populations below that. And then you can see, I mean, the key here is that, you know, in the 70s period where we know that people were identifying, you know, issues associated with the numbers. These are like anecdotal reports and fish biologists suggesting there were fewer, and then really solid data collection really supports the idea that we have more summer chum now returning to Puget Sound than we used to. But you have to be very careful in Puget Sound and the whole state of Washington when you're looking at total adults come back, because we know we've got robust hatchery programs for every species, with the exception of, you know, pink and chum. But for summer chum in Hood Canal, we have relied on hatchery supplementation. And so that's in yellow. And so this is a really, really special kind of story, because you can see that like many places and many species, we've brought hatcheries in as a major recovery tool. But the folks that were involved in the recovery programs and still are, for summer chum have done something pretty unique and special, I think, is utilize these supplementation programs and it's had scheduled end dates or scheduled, sort of benchmarks for when these hatcheries were no longer needed, because the goal is these self-sustaining, locally adapted populations that don't rely on hatchery supplementation. So you can see this period of robust supplementation, and then of course, this yellow becomes a smaller fraction of the total while these green bars sort of take off. You'll also notice, this is some graphs Larry Listell produced. I think they're really nice and they're up to date, very close to, and you'll notice this recent decline as well. So we're sort of like, everybody hold your high fives, because we're noticing that we have a new set of issues ahead of us with summer chum. So this these graphs are showing run size. So that's the number to Puget Sound, and who produced them. Was it a hatchery or wild? The next graph shows the number of fish on the spawning grounds in the same format. So this is cool. If you just I'll go back to that other one, and you keep that in your head, and the shape of these graphs are very similar. And what that means is when we have a large number of summer chum return run size, we didn't go out and harvest them all or change our fishery regime because we thought there was going to be a lot of summer chum. In fact, we kept those rates, those exploitation rates, less than 20%. And so in some places we see these big run sizes come, and then we forecasted those. So we went out and we kept the population low. But you can see for summer chum, they've really given summer chum some breathing room, and the shape of these curves is really like the same shape as the run size. So this is the number of fish spawning, and these red lines represent these bracketed goals on the spawning grounds. So for Strait of Juan de Fuca, you can see places where our number of spawners was actually above the goal, and then you can see places where it dipped. And then we're kind of in that regime right now. So this sort of period of time for the recovery is an exciting one, but it's like a super, super challenging one, because we've got these populations that showed us that they could support themselves. We've still got some that are not, but those that were doing really well, we've seen those decline again. And we can't blame fisheries per se, because we've ramped down those fisheries in a large way. We don't think predators are the major cause. And so these fluctuations, these declines are ones that we think could be climate related. And I'll talk a slide or two about that. So this map, I kind of went back and forth this map looking for the right one, but the idea here is to show these populations and how we're doing. And there's a lot of different colored dots and stuff, but the thing to notice is these brown and gray dots. So you've got one up north here. I think this is Chimacum. And then you've got one south in Skokomish. And then, so we've got those, we've got green dots. So here's on the west side here. And these are all populations that were kind of moving in the right direction. These red ones represent extirpated populations. We've got one on the Strait of Juan de Fuca. And so you can see it's still a mixed bag, but we do have sort of this genetically and spatially diverse landscape that's supporting summer chum populations that it wasn't, in the 90s. So it's sort of a hard map to get a good picture of it, but the graphs before and then the one I'm going to show you, I think zeroes in on a little bit better. So this is, again, years down here, really recent time, and you can see blue and red. This is sort of the recent trend, so you can just track, are we going up or down? And this is, again, just showing that peak and then the decline. And because the shape of these two blues and reds go together, very similar, it suggests that, while the Strait of Juan de Fuca populations aren't faring as well as the Canal, there may be a broader sort of signal of like some other reason for this decline that is not necessarily local at this point. And the 2018 data really supports that idea that, no matter where you're from, summer chum had a really tough time in 2018. So it suggests maybe more of a broader basin scale problem. And this shows the same thing. These are a whole bunch of rivers. I really like this graph, and this is another one Larry Listell made. And it shows, sort of this rebound in recent times of almost all of these independent populations of summer chum. And then, sort of this steady decline in 2018 among all of them. So we like to think about this habitat work as really important, because it is, and it sort of notches these populations up. But then when we see a large scale decline like this, we continue to focus on habitat, but move to other places too and say, hey, what's happening more broadly that's affecting all of these at once? And so I keep sort of mentioning this basin scale thing. So I think I have 2 more slides here. And I'm going to talk just sort of briefly about this idea, this ocean climate, and how this we think is sort of our next big challenge around the corner. So you hear a lot about the Pacific Decadal Oscillation, or the PDO. And so this is a basin scale climate pattern that's described utilizing a whole bunch of information about the ocean climate, but also the atmosphere. And so the sort of short version of the PDO description is that it moves in these sort of warm and cold phases. And it's an area of research I've been heavily involved in, understanding when the PDO is in a warm phase, what does that mean? Like, what does it mean for the ocean climate? What does it mean for the fish and the other, creatures that are depending on the ocean? And what we know now is that when the PDO is warm at red, positive, that's bad. And we know that warm PDO is associated with warm surface temperatures in the ocean. It's associated with El Nino years, drought-like conditions. And it's also associated with changes in the food web that are not good. So these can be, in warm years, we have more rockfish versus maybe more forage fish like anchovies and herring. But we also, even lower down in the food web, we know we have a different type of copepod. Super low trophic levels. We're talking about zooplankton and phytoplankton are actually changing in warm versus cold years. And we think that's due in large part to these large warm water masses that are moving from the south to the north. So bottom line is, it's a bad deal when we're in these warm phases of the PDO versus the cold phases of the PDO. And so for a fish like a chum salmon that migrates out to sea at a very small size relative to our other salmon like Chinook and coho and steelhead, we know they're feeding very low on the food web. So it makes a lot of sense that if we have warm water move onto the continental shelf about the time when these fish are trying to come out to sea, we might have these lipid poor copepods. We might have a different fish community that's being fed on, and that may affect chum salmon and their survival. So a lot to kind of unpack there, but this is the idea. So this graph here shows how we move between these warm and cold phases. So you can see, if you think about like the big El Ninos that you remember, so like 2015 was a big El Nino year. It was in the news. We had complete coastal salmon fishery collapse and closures of fisheries in Oregon and California and parts of Washington. And you can see the ocean climate was warm, PDO was positive, and we had these warm tropical copepods on the coast. You go to the cold years before that, we saw salmon numbers increase for a while, chum salmon, but also other species, and we saw this cold ocean regime with it. So we fluctuate, cold, warm, and these are natural, and these fluctuations used to be about every 10 years. You can kind of track that here, these big warm phases, these are, cold and warm, and cold and warm. And that's why it's called the decadal oscillation. It's about every decade it switches. Kind of a new problem that we're dealing with, and summer chum are dealing with, is that these shifts aren't necessarily decadal. We see these spikes back and forth now. We'll move from one to the other. We had the ocean blob that was this just sustained. It wasn't just a PDO in the summertime trigger. We were seeing for these multiple years, this warm water that was just hanging around the continental shelf. So big challenges, ton of uncertainty, and it's just kind of a new world for the ocean climate mixed with climate change more broadly. So we think this is going to be our next big challenge with summer chum. So this is the zone we're talking about right now where we've experienced this decline. And there's a lot of words here, and this is a really cool graph Larry made as well that I really like. But I want everyone to kind of zero in on this last phase here. This is the El Nino and the big blob that we learned a lot about in the news. So it seems weird that this was actually a time, if you remember, when summer chum were doing pretty well. 15, 16, 17 started to be bad for the strait. And then the 18 year was when things just dropped off. And again, in 19 was bad. So it seems odd that, you know, it took so long for this warm ocean water to affect our salmon. But it makes a lot of sense if you imagine a 4- and 5-year-old fish returning back to Hood Canal. When it went out to sea, like a 2018 return fish, those fish, you know, went out to sea about 3 and 4 years prior to 2018. So that would have been right at the heat of this. So 2015 was a tough year. So if you went out to sea then and you came back as an age 3 or an age 4 summer chum, you experienced that. So 2018 was the first year we saw multiple age classes stack up on that warm blob, so age 3s and 4s. So we're pretty confident that the PDO is significant, and the recovery documents now have described expectations and recovery goals that are very specific to the ocean climate regime that we're in. So again, really big kudos to all those involved in the recovery effort, because there's a really smart approach that's watching all of these things change before us. So the goal is during these really poor ocean years, which happened, you know, 100 years ago, these were occurring, summer chum were able to weather the storm due to all this diversity. And so the idea would be to recover a summer chum species and run type that can weather these big storms that we've got into the future. So in summary, there's only 4 bullets here for the summary, but that was a lot. So if folks have questions, you know, I've got time to answer those this evening. But, you know, the summer chum ESU has experienced an encouraging positive trend, but we're sort of holding our breath a little bit. And, you know, continuing sort of strategic planning for a challenging future. You know, we're adopting, you know, this conservative harvest regime and just continuing to support that because we think it's one of the biggest steps that was taken. You know, strategic supplementation, so really special hatchery programs that are designed around clear goals and timelines. Habitat restoration, we need to keep ramping that up. So, you know, we talk about summer chum weathering the storm, and I think the habitat work is what's going to help us with that. Ocean conditions, you know, influence growth and survival of summer chum. I published a paper last year that documented this decrease in salmon size for all species, and chum were among those, of course. So maybe 50% smaller for these adults that are returning. So big changes for them. And then we really want success during these lower ocean productivity years. So we talked about that. And so this was in my notes that I can't see it, you guys can't either, but these are 3 sort of documents that I leaned heavily on for this presentation, and I'm happy to share those with folks. I think that's all I've got. So I'd be happy to answer some questions if you have them. And then before we go, I want to give a couple shout outs that I have in my introductory slide.
James, this is Linda Herzog. Can you hear me?
Yeah, how you doing?
I'm doing well, thank you. Really interesting presentation. Can you go back about 6 or 7 slides, I think, to the map of Hood Canal where you show the winners and the losers?
Yeah.
I'm curious about that because there's up beyond the hook from the ocean, there's a winner with a star. And it just doesn't make a whole lot of sense that there should be so many other smaller habitats as you go down Hood Canal that are not doing well, and then all of a sudden at the very end there's one that seems to be recovering well. Do you have an explanation?
Yeah, I don't have an explanation for that other than a lot of recovery efforts in terms of monitoring, trapping, habitat work, and also a different river. So I'm going to go back even a couple more, and there we have a nice map with kind of numbered rivers here. So this is pretty important because if you have, and I don't think we've met before, but are you familiar with these systems? Like, have you seen some of them?
Yeah, I live on Quil Bay, and
Oh,
just
great.
casually looking around at things and watching when the salmon come in of various types. But I know practically zero, except what I learned today from you.
Okay. Well, yeah. So there's all these different rivers, and they're all, they all behave very differently. And so the one that you were looking at there was River 21. So that's the Union River, and the Hood Canal Salmon Enhancement Center is like right on top of it.
Right.
It's really a special system. And so there's probably a lot to be said for, there's a lot of people kind of holding hands for the Union River, really helping. But it's also has amazing habitat. It's a little bit bigger than the neighboring one that we were looking at, Big Mission. And sort of as a side note, so there's that it's a little bit different flavor of river. But also we have these large sturgeon that return to Hood Canal occasionally, not to spawn, but they move into Hood Canal and feed, and they're like 4 and 5 foot long fish. And we've got quite a few reports of these things moving into the Union, and also the Tahuya right here, which also I think on our other map is not a winner, but these sturgeon come all the way through the Pacific, past Grays Harbor, past other places they hang out. They move into the Strait of Juan de Fuca and occasionally come all the way into the Hook and hang out in the Union River. And
wow.
If you see them there, I encourage you to go to the Enhancement Center and talk to Mendy Harlow there and ask her, like, call me next time you see one, because it is frightening to see a 4 or 5 foot long fish in this water. But they hang out in there and they really like it. So there's something special about the Union.
Yeah, that's interesting because I did go down and visit maybe about 4 or 5 years ago. It's a beautiful place, and they obviously take very good care of everything that they have responsibility for. But who would guess that the sturgeon would figure that out and come to visit?
Yeah, and I'm going to dig into that a little more because it's a really great question. And I'm thinking Larry Listell is going to answer the question immediately right off the top of his head when we ask him. So
I'm going to mute myself until I have something else.
Great.
James, this is Alicia.
Hi.
And Larry is under contract with Hood Canal Courting Council, who I work for. And he often says that the estuary work, there's been extensive estuary work in the Union as well as the Skokomish, and he credits a lot of that to how well they're doing, especially with the warm PDO years. They seem to be doing better than some of the other watersheds.
Yeah, so it kind of stabilizes those populations in a way that maybe the other ones don't.
Yeah, it may have something to do with that food web, yeah.
Okay, that's really helpful, thanks. Yeah, if there's no immediate questions for this presentation, I can bring it back up, but it's really important to me that I get these notes for, so there's all these people that I chat with often about summer chum, and I used to work in South Puget Sound specifically, and I was watching this summer chum recovery effort and helping where I could. And so you bump into all these pieces that have really taken ownership, all these people that have taken ownership for it. And so I made kind of this short list. And So Larry Listell, of course, you can't find a summer chum document without his name on it. I know he's poured a huge portion of his career and passion into that. Mark Downen is a colleague of mine, Fish and Wildlife. Scott Brewer, of course, Hood Canal Coordinating Council, who's an awesome person and the same committed to this. Scott Bass, Norma Sands, Noah, Tom Johnson, and then all the co-managers, and then folks that have specific research questions, Barry Berzikin, Maureen Small, and myself have been involved in some of the research aspects. So I'd be happy to help put people in touch with any of them who are for sure experts on this topic. And then the last thing I'd say, I showed, a few documents there, and if folks are interested in reading more, Alicia, my guess is you've probably got a handle on those, but if there's one there that you didn't have, or if anybody else wants to read more, there's some of these are actually pretty good reading material. So
yeah, the guidance document that Larry wrote for Hood Canal Coordinating Council, that can be found on our website library as well.
great. Well, Alicia, I would ask, if you work closely with Larry, is there anything you want to share with the group that maybe I missed that, or maybe that I didn't know?
Yeah, and I guess another document that would be really important for people that are learning about it is the recovery plan itself. So you cite the guidance document to update the recovery goals, but the original document that incorporated all of the conservation regime and along with that guidance document really is the path forward that all the partners are taking together. So I think that's just the emphasis on that.
Great. And then Larry's working on a review right now, isn't that right?
So
that'll be really nice.
Yeah, Hood Canal Coordinating Council is putting out is going to update the recovery plan, and we've contracted with Larry to work with us on that, and of course all the co-managers and partners.
Cool.
So I guess that, yeah, and the big update to that is going to be a harvest regime. So really looking at, we think there's a point where we can open up harvest very soon, and that'll help all the co-managers in harvesting other species, because a lot of the harvest is bycatch on other fisheries. So that would be a big step moving forward towards recovery.
Sure. That makes a lot of sense. Well, again, my name's James Losee. If there's somebody that, folks want me to put them in touch with, or if there's questions I can answer, please email, and we can keep in touch. But I really appreciate you guys coming. And if you talk to folks at Hood Canal Salmon Enhancement, they're great friends. Let them know thanks for having me. I'll chat with them too, but this was fun.